Ladies and gentlemen, today we will talk about how we can use electric vehicles as an energy storage and the potential for vehicle to grid. In this lecture, we will first learn what vehicle to grid means and what are the benefits of using an electric vehicle for this purpose. Finally, we will look at how we can implement vehicle to grid and what are the key challenges in this respect. Vehicle to grid refers to the concept of using the electric vehicle battery to feed power back to the grid. Vehicle to grid uses the electric vehicle not only as a means of transport but as a battery on wheels capable of energy storage. Besides the grid, the energy in the battery can be fed from the vehicle to a building, to a home, to a load, and it is called vehicle to home V2H, vehicle to building V2B, vehicle to load V2L respectively. Vehicle to X or V2X is a generic term that is used to include all such applications. There are several key benefits of vehicle to grid technology. First, vehicle to grid enables the storage of electricity in the car, especially from renewable sources, which leads to the dual benefit of managing the variations in the renewable energy production, but also reducing the emissions of electric mobility due to the use of sustainable sources of electricity. Second, vehicle to grid can be used for peak shaving by feeding the energy stored in the battery back to the grid at moments of peak electricity demand. Vehicle to grid can also be used as a backup energy storage when there are grid blackouts or complete power failures. Lastly, ancillary services like frequency control and voltage control can be offered to the grid using an electric car with vehicle to grid configuration, providing a revenue stream to the user which is much larger than what is possible with smart charging. All the advantages of vehicle to grid are possible due to the large size of the electric vehicle battery. To quantify this, a typical electric car battery can store about 30 to 100 kilowatt hours of electrical energy. On the other hand, the battery of an electric bus or a truck can store much higher, between 100 to 500 kilowatt hours of energy. Such large batteries can hence be a huge powerhouse and they can power a house for several days, if not for weeks. Besides the energy perspective, an electric vehicle battery via vehicle to grid can also be a significant source of power. If you take the case of each vehicle being able to deliver 10 kilowatts of power and a mere 100 cars, they can together provide 1 megawatt of power when required. Such a virtual power plant can play a key role in future grids with large scale of variable generation from solar and wind energy. Let us now talk about how to implement vehicle to grid technology. The most common way to charge an electric vehicle is to use alternating current or AC charging, where an onboard AC charger with a power rating of up to 22 kilowatts converts the AC power from the grid to direct current DC power from the battery. However, vehicle to grid is currently not possible using the AC chargers. This is because a bidirectional onboard charger is needed for vehicle to grid, but most current electric vehicles only have a unidirectional onboard charger. That is, they can transfer power from the grid to the battery, but they cannot transfer the power the other way around. Therefore, we need bidirectional onboard chargers which can do the power transfer both ways. Further, vehicle to grid requires higher levels of communication between the electric vehicle and the charger, and this is not fulfilled by simple pulse width modulation or PWM communication, which is present in Type 1 and Type 2 alternating current AC chargers. Hence, bidirectional off-board DC chargers are used for vehicle to grid applications, which are based on CHAdeMO and combo charging standards that use a higher level of communication between the electric vehicle and the charging using PLC or power line communication or CAN or control area network communication. It is vital to keep in mind that even though direct current chargers can be rated for as high as 350 kilowatt, V2G powers are usually much more limited, typically in the or about 20 kilowatts. Also, not all DC chargers are bidirectional V2G capable. Despite its benefit, there are several key challenges for vehicle to grid that are identified as well. First, vehicle to grid needs bidirectional chargers which are bigger and more costly than unidirectional chargers. Second, the lifetime of the battery inside the electric vehicle could be reduced since the bidirectional charging demands more charging and discharging cycles from the battery. Further, the ICT infrastructure requires standardization and the regulatory framework, and the financial incentives which are essential for the implementation of vehicle to grid are still under development. So, to summarize the lecture, first we saw what is vehicle to grid and how we can use a battery in vehicles to power grid, buildings, and homes, individual loads, to constitute the general term vehicle to X or V2X. We saw how the large size of the electric vehicle battery with a magnitude of 30 to 100 kilowatt hours and the ability to provide up to 10 kilowatts of power per car makes electric vehicles an excellent source of both energy and power. Because of the absence of bidirectional onboard chargers, vehicle to grid is currently implemented using off-board direct current DC chargers. The key benefits of vehicle to grid are storing renewable energy, reducing the peak demands, providing emergency backup power, and providing ancillary services to the grid. The main challenges are the need for bidirectional chargers, higher battery degradation, the required development in ICT standardization, and financial incentives for the users. Thank you for listening.